Hello everyone, we are Team 6 and this is our SC1015 Mini-Project. Through this project, we aim to predict what influences the popularity index of a song more, its lyrics or parameters like danceability, energy, tempo, etc. The motivation behind this project was to let the artists know what feature of the song that they should focus on more so that they can release more chartbusters. We extracted our datasets from Kaggle. We have used two datasets in order to fit a problem statement, one for lyrics and the other for parameters like danceability, energy, etc. Both the datasets had two files, the other one being a repetition about the names of the artists. We chose not to include those in our project because it seemed to be rather redundant. This is our first dataset on the features of the songs, which include danceability, energy, key, duration, etc., as well as popularity index, which is the variable to be predicted. This is a second dataset which contains the lyrics of the songs. For cleaning the data of the first dataset, we have dropped the duplicate songs and NA values, as can be seen from the code snippets provided. As a result, the total number of rows have reduced from 586672 to 446474 from raw data to clean data. Additionally, for better accuracy, we have also carried out min-max normalization for scaling numerical data to a fixed range, typically between 0 and 1. For dataset 2, we have dropped duplicate songs as well as NA values. Also, we have renamed the column SName to name in order to aid the merging of datasets later. Using the column of name of songs, we have merged the two datasets. This is how we have prepared the dataset in order to perform a machine learning analysis. We then performed data preprocessing for cleaning, transforming, and preparing raw data to make it suitable for analysis. This is a crucial step in the data analysis pipeline as the quality of the output of data analysis is highly dependent on the quality of the input data. Our data preprocessing steps include conversion of characters in the lyrics column to lowercase in order to increase the consistency while analysis. We have also removed the stop words, which are common words that are usually removed from text data during preprocessing because they do not carry much meaning. For our dataset, these were non-alphabetic characters, white spaces, emojis, etc. We also performed stemming, which is a process of reducing a word to its base form by removing its affixes. It normalizes words and improves natural language processing tasks. And then finally, tokenization, which is breaking down a text into individual words or phrases known as tokens. It facilitates NLP tasks like text analysis. After doing all these data preprocessing steps, we recombined the clean text string and returned it. After cleaning and preprocessing, we moved on to exploratory data analysis, that is called EDA, to gain some data-driven insights. We created scatter plots of all the numerical feature variables against the popularity index, that is the variable to be predicted, to get a visual sense of the strength of correlation between them. These are two of the plots, liveness against popularity, which seems to have a very poor negative correlation, and loudness versus popularity, which has a fairly positive correlation. We plotted box plots for popularity against categorical variables, which include mode, key, and time signature. We divided the popularity index against different categories of these variables to make the box plots in order to find out how different categories influence the popularity index. Here we have shown the box plot for mode against popularity. This is done to visualize the frequency of the various popularity indices and how they are distributed. And here, by extracting the top 20 words occurring in the lyrics, we took out their frequencies and represented it as a bar plot. We tried to go beyond our course while doing this EDA. We learned how to do data preprocessing, which is an integral part of any NLP task. We learned several new Python functions for it and applied concepts like stemming, tokenization, etc. Then we came to the models part, where these are the models which we use in our project for prediction of the popularity index. These models are for the numerical dataset that included the features of the song. We are using sequential neural network as a main machine learning model. We expect it to run better than our other two baseline models, that are random forest and linear regression. For all the models, we used a training dataset and a test dataset, which are formed by splitting the original dataset into 80:20 ratio. Sequential neural network. So this code creates a neural network model using Keras sequential API. The model architecture contains 4 layers. The first layer is a dense layer with 32 nodes and a rectified linear unit activation function. It takes an input with shape, that is number of samples, number of features. The second layer is another dense layer with 16 nodes. The third layer is a dense layer with 8 nodes, and the fourth layer is a dense layer with a single node and the linear activation function, which is used for regression tasks. Each dense layer is fully connected, meaning that each node in the layer is connected to every node in the previous layer. The activation function introduces non-linearity into the model, allowing it to learn complex relationships between the input features and the target variable. This is a supervised learning approach that uses a labeled training dataset. So, this is our first baseline model, random forest. It combines multiple decision trees to form a forest of trees. Each tree is trained on a randomly selected subset of the training data and a randomly selected subset of the input features. The final prediction is made by aggregating the predictions from all the trees. The n estimators parameter here specifies the number of decision trees to include in the random forest, and for our model we have used 100 decision trees to build the random forest. We use linear regression as a second baseline model, and the goal of linear regression is to find the best fitting straight line relationship between the features and the popularity. This is one of the simplest supervised learning models. Moving on to the models for the lyrics dataset, we are using LSTM, that is long short term memory, as a main machine learning model, and we expect it to run better than a baseline model, which is linear regression. For both the models, we use a training dataset and a test dataset, which are formed by splitting the original dataset into 80:20 ratio. We have used Keras API for building neural networks. Here, this sequential model has been built with the following layers. An embedding layer. This layer is used to convert the text data into numerical vectors. It helps to associate similar words. A bidirectional LSTM layer with 64 units that can remember long-term dependencies and sequence data. It is used to capture context of the sequence. Another bidirectional LSTM layer with 32 units. This layer also processes the input sequence in both directions and helps to capture deeper context information. A dense layer with 64 units and ReLU activation. The dense layer takes the output from the LSTM layers and applies a linear transformation to produce a new set of features that are useful for predicting the target variable. A dropout layer with 0.5 dropout rate. Dropout is a regularization technique that randomly drops out some of the units in a neural network during training to prevent overfitting. And 6, a dense layer with 1 unit and linear activation. This layer produces the final output, which is a single real number representing the predicted value. We have used linear regression as a baseline model to train the lyrics dataset. Now we move on to comparing the accuracy of the results produced by our models. First, for statistical data, so we obtained the best results with neural networks. It yielded a mean squared error of only 0.026, which is less than that given by both our baseline models used for the statistical data. Linear regression model yielded an MSE of 0.027 and a poor R-square value of 0.23. Random forest model yielded an MSE of 0.16. For this, linear regression performed better than random forest, and this could be due to overfitting in the random forest model. Overfitting happens when a model is too complex and fits noise instead of patterns in training data, leading to poor generalization on new data. Random forest models tend to have more flexibility than linear regression models, which makes them more susceptible to overfitting. We move on to the lyrics dataset. So we obtained the best results with LSTM. It yielded an MSE of only 0.045, which is less than that given by our baseline model. Regression model performed badly as it yielded an MSE of 10.76. So, coming to the final inference. Since the MSE of statistical data, that was 0.026, is less than that of the lyrics data, 0.045, we conclude that the statistical features like liveness, tempo, danceability, etc. are better predictors of the popularity of a song than its lyrics. Thus, our inference would be that artists should focus more on these statistical features than on lyrics in order to compose more chartbuster songs. Thank you.